So this is lesson 1.8, the problem set in elementary algebra. And problems 1 through 16 are just asking you to answer some questions given the problems there at the top. So let's just do one there just so you have it down. So there's what they give you. They give you the 3 sets and then they ask you some questions about it. So for example, number 4, it says, tell me what A intersects C means. What is in common with A and C? There's nothing in common, so do not put a 0 down. 0 is a number. Nothing in common, you get the null set. If I ask you something like number 8, C unions the quantity A intersects B. Again, you use PEMDAS. You do what's in the parentheses first. So C unions, what is A intersects B? What is common to both A and B? Well, I have a 2 here, and I have a 4. So the numbers that are common to A and B is the set 2 and 4. Now they want us to combine that, or they want to union it with 1, 3, 5, 7. So remember, union means that it's in both sets. So C has 1, 3, 5, and 7, and then I've also got 2 and 4. So the answer is going to be the combination of all of those because it's a union. So that's how you would do that one. Be 1, 2, 3, 4, 5, and then 7 because 6 is not a part of that. Alright, so let's jump to 12. So again, this is the instructions, and this is what we're looking for. X such that X is an element of B, but is not an element of C. So what are the elements of B? The elements of B are 1, 2, 3, 4, 5. So according to this, X has to be an element of B. It has to be one of those numbers, but it cannot be a number that's also in C. Well, 3 is in C, and 5 is in C. So the only options we have then for 12 are 2 and, oh, nope, there's a 1 in C as well. So 2 and 4 are the only answers we can have. So 2 and 4. And don't forget to put your answers always in those cool little set signs like that. Alright, so that's 1 through 21. And as you continue on, it asks you to list whole numbers, rational numbers. You're going to have to go back in your book because I didn't cover rational numbers and irrational numbers. So you're going to have to go back and look at that. Real numbers are basically every number out there. Real numbers includes positives, negatives, fractions, decimals, rational, irrational, all of those numbers. Rational numbers, just to give you kind of a real quickie on that, are numbers that can be written as a fraction. Irrational are numbers that cannot be. Some examples of a rational number would be like pi. Pi can't be written as a fraction because it's 3.1415 and it goes on forever, so we can't really write that one as a fraction. It's an approximation of pi, but it's not exactly what it is. Square root of 3. There's not two numbers multiplied together that are going to give you 3, so that means it's an irrational number. We can't write that as a fraction. So anyway, there's your lesson on rational and irrational. Let's go to 35 to 40. They're asking, are these composite or are they prime? And if the number is composite, then factor it down. So number 35 is asking you to take, let's get rid of some of this, asking you to take 48, and I know it's composite because it's even, and I'm going to do the factor tree. Prime, 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 prime. So I have 2 4 times 3. Those are my factors of 20 or 48, my prime factors because it is composite. 41 to 56. It says factor the following into the product of primes, which I just did on the screen right there. And when it's been done completely, write its prime factors from smallest to largest, which I did. And I put the exponents on there as well. So what I did for this one, number 35, is the exact same thing you do 41 to 56. And that's it for problem set 1.8.